what machines can be doing. We're kind of starting to talk about it there with, maybe one agent has encoded what a blueberry feels like. And so it's able to be able to delicately pull blueberries, and this, sharing that information with other agents that have other expertises could allow for innovation to happen. So, maybe there's another agent that knows how to use solar power to move a vehicle around a field. And so, those two together can say, oh, wow, we should be making a solar powered blueberry picking device. And so that kind of gets me thinking about the same kind of vision for the future that you talked about a little bit in the previous episode. So in episode 941, you talked about how drug discovery could potentially be accelerated by by agents working together. So you could have LLMs planning the research. You could have protein folding models exploring shapes, nucleotide configurations that lead to new kinds of proteins. Robots running wet lab experiments. Compliance agents monitoring everything. So with decentralized artificial superintelligence, with that framework, how does that kind of pipeline that you were describing in your previous appearance on the show evolve?
Right. So that's a super, super awesome example there because it brings in capabilities that cross vertical boundaries. So let's think about drug discovery, where you have maybe a large language model that allows you to first plan for what you're trying to achieve. So this is the goal building exercise and iterating exercise. So you want to build or create a drug that does X. So when you build a plan for that, you actually want to define the problem, the goal really carefully and iterate with a large language model to then break down that goal into discrete tasks. So that's step number one. And you figure out which parts of the task goes to which kinds of agents moving forward. So that's the first step. And then from that, you might go into an agent that is based on an AlphaFold like scientific foundation model that is doing the protein folding exercise and exploring that space in a pretty comprehensive manner. From that, AlphaFold is going to give you a set of possible outcomes that look interesting, and you want to test that against these compliance agents, these effectiveness agents, these manufacturability agents, and so on. And so that's what you do next, and that's an iterative curve itself that you'll have to go through for a long time till you narrow the space further down and get to, yeah, maybe these are the 10 options that I want to take and do some wet lab experiments, actual rubber meets the road kind of situation here. And then you get into physical AI or embodied AI, and you have a bunch of these robotic labs doing these wet lab experiments to make sure that it passes muster in the physical world before you get into maybe human trials or even animal trials for that nature. And so this entire pipeline is going across multiple kinds of models from various vendors who are experts in each one of these things. And they need to get connected and talk to each other. And that's where the world is today. So just being able to pass messages is where the world is today. And that's what we're doing with agency and A2A and MCP and all of the work that's happening today. But then all of these entities need to then share common intent, which is let's build or create a drug for this specific purpose with this price point in mind, with this population in mind, with these risk characteristics in mind. So that is the goal that needs to be defined, and that is the shared intent. And so you need a set of semantic protocols to make sure that you iterate on that, make sure you discover information, resolve conflict, negotiate, coordinate, and get to a common goal. So that needs to happen. Then we need shared knowledge because as you're doing these things, as you're iterating between the compliance agent, the manufacturability agent, and the protein folding agent, they need to share knowledge and look at what's worked, what's not. The compliance agent even needs to pull from the past and say, you know what, even if this looks like it's going to work, you're going to get stopped when you're looking for approval from FDA. So there needs to be shared knowledge, and you need to add to it, redact, modify. And then finally, you need these guardrails and cognitive engines that are doing guardrails and acceleration so that you can do these experiments faster, but within the boundaries of what's possible. And so that's the shared innovation that needs to happen above the shared intent and the shared knowledge layer. So that is how I see the drug discovery of the future that's going to happen, that's going to make me a healthier person and make me live for 200 years and let me play the guitars that I still have to pick up and I still don't know how to play.